Division is, what did you write down? What did you hear a neighbor say? What have we already learned about what division is? Division is what, Eva?
Always fair.
Division is always fair. Can you explain what that means, Eva? If something is always fair? What does that mean if I'm dividing and I'm always fair? What does that mean?
Like if somebody, like a person has 4 muffins and they want to give them 2 muffins, then that person that had 4 muffins would probably have the same amount.
Yeah, so if I'm dealing out and I'm giving 2 muffins to Eva and 2 muffins to Brian, that's fair. What if I gave 15 muffins to Eva and 2 muffins to Brian? Is that good division?
No.
No, because that's not fair. That's not fair. All right, what else can you tell me? Division is what, Ella Harris?
Division is the inverse of
Ooh, that fancy math word, inverse of multiplication. What does that mean, Ella? Yeah, we're talking about the opposite. Think about the relationship between addition and subtraction. You guys have done a ton with addition and subtraction since somewhat in kindergarten. You know those two are opposites. Same thing with multiplication and division. Those two operations are opposites for the math term inverse. Good. Grace, division is?
dividing.
Division is dividing. Sure. Division is dividing. Yeah, division is dividing. What is one of our strategies that we use when we are dividing? 2 people know. Holy moly. What is the strategy that we use when we're dividing? That is not a trick question. Holy moly. Y'all are scaring me this morning. Aiden?
Passing out.
Yeah, we have dealing out. 1 for you, 1 for you, 1 for you. We have dealing out as a strategy. Any other strategies? Taylor? Yeah, we're going to talk about this one some more, but flipping the equation. So if you look at a multiplication equation, you can flip it around to be a division. And then if you see a division problem, you can flip it around to be a multiplication. Sure. Any other strategies? One more. We kind of tend to do it when we deal out. Parker? Go for it. 3 plus 2 is 5. 5 minus 3 is 2. Put it back there. Yeah, it's the same setup for multiplication and division. Right. Yeah, bar models. You can use bar models for pretty much any math, but yes, definitely a strategy that we're going to be using a lot today because I like it because it helps you figure out what math am I supposed to do. Georgina?
We could, well, for the strategy for the division is, he takes the number and you take the other number. For example, 4 divided by 8 equals 2 because it takes 2 4s to get to 8.
Yes, it's backwards, but yes, it's 8 divided by 4. So that's okay. Okay. So the other equation, or the other strategy that we talk about is just equal groups, where you draw the circles, and then you can put the number in. Right, circles and dots. We love some circles and dots. Anything else for division is? Division is what right here?
Fractions.
Ooh, I'm going to write that up there. I like where you're thinking, and technically, yes, we will hit that much later on when we start learning about fractions, but you are correct. Division is fraction. And if you know what a fraction looks like, kind of looks similar to a division symbol.
Yeah, it does.
Weird how that happened. You know what a fraction looks like, Parker?
Yeah.
Oh.
Yeah.
That's a fraction.
Yeah.
That's
Oh,
what number.
that's
That's fourth grade math.
Is it? No, it's not. That's 100% third grade math. It's just third grade math in equal.
It's multiplication, just taking away the dice,
Isn't that
just
correct?
adding numbers.
Kind of. But we're not going to touch on that. So if you have no idea what I'm talking about, that's okay. Fractions is what we'll do in March and April. Don't worry about it right now. Aiden, division is...
How many times a number goes into a number?
Ooh, I like that. How many times, this is kind of banking on what Georgiana said earlier. Man, my marker is struggling to keep up today. How many times a number can go in another number? So we're thinking back to what Georgiana said earlier. She said 8 divided by 4 is 2. Meaning she can fit 2 4s into an 8. Yep. Yep. I like that language, Anne. How many times a number can go into another number? How many times can you fit it? What if I could only fit it like 1.5 times? Would that be fair?
Yes.
Like, let's say I wanted to do 6, the number 6, and I wanted to see how many times I could fit 4 in there. Would that be a number that would divide very well?
No.
No. Is it going to be fair? No. It is not going to be fair.
4 and 2.
Yeah. It's going to be 4 and 2, which is not fair. Tricky. Mason, you good? We good? You got this in your notebook? Susie, you have not a lot written down, and I have a lot written on the board.
Everything.
Susie, do you have this written down? I'm not staying on this page very long. What's up, Anna? Part, whole with addition and subtraction. Kind of remind yourself, what does that look like with addition and subtraction? You've done it before, so it should be easy. And then we're going to try it with multiplication, division, and see if we can master it. What's up? Because that's what we're going to be doing today. Thank you. Okay, so your subtitle is part, whole. Alright, this looks a lot like word problems. What should be my first step in a word problem? It's super tricky, super hard. Read it. You need to read it. Jenna just baked cookies. She has 12 cookies cooling on a tray and 10 more in the oven. How many does Jenna have? How many cookies does Jenna have? What is our unit? What is our unit? That is always step number 2. What is our unit? What are we counting in this problem? Right here?
Cookies.
We are counting cookies. So what is going to be our answer sentence? Eva?
How many cookies?
That sounds like a question. I want a sentence.
I got.
Okay, Brian, you want to give it a try?
Jenna cooked blank cookies.
Jenna, we could say Jenna cooked or baked blank cookies. Jenna has blank cookies. Whatever you want your answer sentence to be, go ahead and write it down. After you have drawn your bar, we always start with what the entire bar is equal to. What does the bar equal? The whole, the total, and in this case, we want to know what is the whole or the total amount of cookies. Cookies. Do we know the total amount of cookies? Don't answer, read the problem again in your head. Do we know the total amount? Does it tell you in the problem, she made this many cookies?
No.
No.
So question mark.
So do we know the whole?
No.
No. We do not know the whole. Do we know any parts?
Yes.
Yes.
We do. Yes,
Yes.
we
Do
do.
we know any parts? Parker, what's one part that we know? 12 left. Yes. We know she made 12 cookies. They are cooling on a tray. We know she's got 12. Is there any other parts that we know? Natalie? She's got 10 more in the oven. So we know our 2 parts, but we don't know our whole. What math operation, what math skill would we use to figure out the whole? I've got 12 cookies, cooling, and we're in the oven. She wants to know how many it's going to have total. What math skill? Ella? Is it going to be blank plus 10? When we do addition, what do we add together? When we are using addition, and we're using part, whole, what are we adding together? Cord?
The 2 parts.
Yes. So part, write this down, this is important, plus part equals whole. And draw a fancy box around it, because this is going to be our focus today. Part plus part equals whole. For addition. Like 99% of the time. For 3rd grade, 100% of the time. Part plus part equals whole. Remember, this 12 is a part, and this 10 is a part. Knowing that addition is part, whole, would it make sense to use addition?
Yes.
Yes.
Yes, because we know 1 part is 12 and 1 part is 10, and I can easy peasy add those up to give me my whole. So I have 12 plus 10 equals W, or question mark, or box. What if I wanted to see if I could use subtraction? What if I didn't know it was addition, and I thought, maybe it would be subtraction? What do I start with when I am subtracting? I only have 2 options, either parts or whole. Which one do I start with when I'm using subtraction? Natalie? I start with the whole. What do I take away from the whole? You don't really have many other options. Cord? Well, one of your parts, right? And that equals the other part. Put another fancy box around that.
It's actually just backwards.
Hey, it's actually just backwards. What do you mean by that, Aiden?
It's part equals whole. Whole plus part equals part.
Whole
Minus
part equals part. I wonder if addition and subtraction are opposite.
They're in the inverse.
They are exactly opposite. Somebody said that wrong.
Inverses.
They are inverse. Addition and subtraction are opposites. We know that, and now you just proved it to me. Now, let's fill in our subtraction equations just to see that it doesn't make sense to do subtraction. Ella, what's our whole? What is our whole? Yeah, question mark. Minus, what's 1 part, Kaiser? 12. Equals the other part, Susie? 10. Does this equation make sense for us to do?
No.
No. Which one would be easier? The addition problem. Go ahead and solve it. Get an answer for your question mark. And make sure your answer goes back in your answer set. write down what Aiden said earlier. Addition and subtraction are opposites. We already knew that, but if you look at our two equations that we made with our fancy boxes, we can see that. Addition and subtraction are opposites. What's up, Gabriella? Great. Put it on your notebook. Put it in your answer sentence. Make sure you write down addition and subtraction are opposites. Knowing this, it'll greatly help us as we start trying to do multiplication. What's up, Ada?
Is it 2 T's for the word opposite?
No. Stephanie has 5 pencils in her pencil box. She used 1, and her neighbor asked to borrow 1. How many pencils are in her pencil box now? What is our unit? What is our unit? Cheyenne, what are we counting in this problem? We are counting pencils. What could be our answer sentence? Go ahead, Cheyenne. Yeah, Stephanie has blank pencils now. Stephanie now has blank pencils in her pencil box. Any variation, as long as it's around those lines, you're good. Make sure you have an answer sentence. If you have not gotten one, you need to make sure you got one. The bar always equals
The whole.
the whole or the total. In this case, okay, that can be read, that's cool. In this case, what are we counting again?
Pencils.
Pencils. So we need to know what is the whole or the total number of pencils. Look at that problem one more time. Read it in your head. Does it tell you the total number of pencils? Think. Raise your hand. What do we think? Does it tell us the total number of pencils? I would read that answer sentence. How many pencils are in our pencil box now? Did it tell you how many were in our pencil box?
Yes.
Does it tell us the total?
No.
Yes.
Yes. Read that first sentence. Stephanie has 5 pencils. It tells you how many she's got. She's only got 5. Stephanie has 5 pencils. I cannot make it more clear than that. So do we know the whole for this problem?
Yes.
Yes. Skippy, skippy.
So it's 26.
5 pencils. Do we know anything else? Do we know anything else? This is a tricky one. This is a tricky one. Do we know anything else? Courtney, what else do we know? Her neighbor asked to borrow 1. Anything else happen? Grace, did anything else happen? Yes. Yes. Her neighbor borrowed 1 and she used 1. So how many pencils just came out of that pencil box? 2.
3.
So one part that we know is that she took 2 pencils out of the pencil box. From the problem that is written, do we know the other part? Now I know you guys know what the other part's going to be because you're math geniuses, but from that problem, do you know? No. So our other part is going to be here. All right, what's our part-whole equation for addition? Raise your hand and tell me an addition equation. I'm not saying it makes sense, but go ahead and tell me what the addition equation is going to be. Parker, go for it. Okay, can you put the numbers in? 2 plus question mark equals what? 5. There's my part plus part equals whole. Let's see if we do a different operation, if it makes it a little bit easier. Let's try the subtraction equation. Somebody tell me, what is the subtraction equation? Ella?
5.
Whole or 5? Yep.
Minus 2.
Minus 2, that's one of your parts. Equals the other part. Could you use either of those equations?
Yes.
Yes, you could. 2 plus something equals 5. Can you figure that out?
Yes.
Yes. Can you figure out 5 minus 2 equals something? Yes. I don't care which one you use. Whichever one makes your brain happy. But these two equations work for this problem. Solve it. Figure out what your missing part is. Put it in your answer set. Stay down, drink water correctly. Georgina, what's up? Okay. Solve it. Fill in your missing part. Fill in your answer sentence. How are addition and subtraction related? We just talked about this. We just proved it with those two equations. Kaishir, how are they related?
Multiplication.
Whoa.
I mean, addition and subtraction are inversely related.
Yeah, meaning they are
Opposites.
opposites. Part plus part equals whole. Whole minus part equals part. They are literal opposites. They go completely backwards. If I turn it around, maybe. Okay. They are opposites. We know that. We know that. Yes, ma'am, Grace. Nope, you don't need to write that down. If you think you want to, because it's going to make you remember it better, that's totally fine. But we're moving on here soon. Okay? We just proved this and subtraction are opposites. We know how they are opposites. We can see the different equations. Let's look at the relationship between multiplication and division. We already know they're opposites. You told me that in our warm-up, that division is the inverse or the opposite quickly of multiplication. Now you have to prove it to me quickly. We're going to do the same kind of bar models to prove, hey, these are opposites. Alright, take a look at this problem. Now it's going to be a little different when we're thinking part whole for multiplication. Because remember, we're talking about groups of lots of parts. Like part plus part plus part plus part plus part plus part. It's going to be a lot.
Yeah, like repeated addition.
Oh, weird. Weird. Justin bought donuts for his class. He brought 3 dozen donuts to share. How many donuts did Justin bring to class? What is our unit? Holy moly, I should see like everybody's hand. Don't stress me out like that. What is our unit? Eva, what is our unit?
Justin bought blank donuts for his class.
Yeah, that would be our answer sentence. We're counting donuts. Go ahead and write your answer sentence down. Once you've gotten it written, go ahead and draw your bar. We're going to get ready to rock and roll on this. What's the first step after we get our bar drawn? God. It's going to make me have a heart attack. We've done this so many times. Brian, what's the very first thing I do after I draw my bar? Courtney? Before then. Emily? Let's be a little more specific. I always start with one section. Bella? The whole. I always start with the whole because that's pretty easy to find. My whole or my total. Someone remind me, what am I counting in this problem? Say again, what am I counting?
Donuts.
Does it tell me in the problem the total number of donuts that he brought? No. So do I know the total?
No.
No, it told me some math, and I could figure it out, but it didn't say Justin brought 5 donuts. It didn't give me easy sentences, did it? No. No, so we do not know the whole. Okay, that's supposed to be a question mark for the whole. When we're thinking part whole of a problem like this, we need to think about groups. What are our groups in this kind of problem? Bringing donuts. How do donuts normally come?
In boxes.
In boxes. How many boxes do you think he got? Probably 3. Because donuts usually come a dozen a box, right?
12.
Alright, so let's make our 3 groups. Here's box 1, box 2, and box 3. Does anyone not know how I did that? Are we good on how I figured out that? Are you good or need help? You're good. Brian, you good? Yeah, you good. What came in those boxes? No, that's not a number though. Because I have this weird vocabulary word. Ugh.
Donuts could be a number.
0. What does that mean? Things that usually come in a dozen. Donuts, eggs, usually come in a dozen. You can buy them more than that, just like you can buy more than a dozen donuts. Pork? 12. A dozen is 12. Write that out to the side so you remember that, because I promise we'll see that again. A dozen, the word dozen, my marker will decide to write today, is equal to 12. Holy moly, that is driving me nuts. Dozen equals 12. So how many donuts came in box 1, Kaylin? 12. Gabriella, how many donuts came in box 2? 12. Dylan, how many donuts came in box 3? 12.
Repeat addition again.
So I could set up an addition problem, correct? Correct? Yes. Somebody help me do that.
Equals 3.
Somebody help me set up my addition equation. Aiden, you were quick to say repeat addition. Help me set up my addition equation.
12 plus 12 plus 12.
Part plus part plus part equals whole. That means, could I set up a subtraction problem?
Yes.
Is subtraction probably going to be very helpful? Probably not. How am I going to set up my subtraction problem? You wrote it in your notebook. You don't know how to set up a subtraction problem. Look back at the subtraction problems we just did. When we subtract, do we start with a part or do we start with the whole, Dylan?
Whole.
The whole. Whole, in this case, we don't know, minus part. In this case, minus another part equals part. That looks super tricky. I don't think I'm going to do that at all.
No.
That sounds awful.
The 1 plus 1
Can I do a different math skill?
addition.
Yes.
Addition.
What math skill could I also do? Georgina?
Counting them.
Math operation. Addition, subtraction, multiplication, division. When we are doing part, whole for multiplication, it's going to be groups. I have one group here, one group here, one group here. You're counting how many times you broke it into boxes. How many boxes did I break it into?
3.
3. Go ahead and write this down. 3 times. What's my other part that I'm looking for multiplication? Groups. And then what for? 12. What's inside those groups? How many is in one group? Which equals our whole. actually part times part equals whole. Kind of. Great? Could do division. Could do division.
What's division number?
When we do division, do we start with one section or do we start with the whole? The whole, write this down. The whole divided by what? You could do 12, something in the group, which will give you how many groups? 3.
Backward. Just a little bit weird.
Because they're opposites.
Because they're the opposite inverse.
Crazy. Now what's up?
I realized that division and multiplication are kind of related because they both start with the whole.
Does multiplication start with the whole?
Or division and subtraction.
Division and subtraction have to start with the whole.
Because
Does addition and multiplication start with the whole?
they start with a part.
Weird. Let's try one more and then we'll talk about it. Jason, hang on. Jason was baking chocolate chip cookies. He wanted each cookie to have 6 chocolate chips. He has 36 chocolate chips. So how many cookies can he make with 6 chocolate chips in each of them?
He's obsessed with chocolate chips.
This is tricky. Think about what you're counting. Then write an answer sentence. That'll help you out a lot. Think about what you're counting. What? Sure. He can make blank cookies with his chocolate chips. This is a very tricky one. Because we need to know chocolate chips, we need to know cookies, blah. We kind of have to count both. So now I said, wouldn't we be counting cookies instead of chocolate chips because we have blank cookies? We kind of have to keep track of both. We have to know how many chocolate chips he has to know how many cookies he can then make. You know what I mean? Okay. I got my bar. What is the very first thing I do with my bar? Sam, what's the first thing I look for when I got my bar out? The whole. Do we know the whole or the total number of chocolate chips that he has?
Yes, 36.
Yes! It tells me in the problem. He has 36 chocolate chips. So what is the whole? 36 chocolate chips. Question? Go on, go ahead.
If we can't we just do an array and have
It's division.
make 6 in each one, and if we get to 36, let's see how many cookies we get.
Hold on to that thought. Hold on to that thought. What else do we know? Stand or sit in your chair correctly. What else do we know? Parker, whatever you're doing, please stop. What else do we know? He's got 36 chocolate chips. He's going to be trying to make some cookies. What else do we know? We know another part. Ella Harris, what other part do we know? He wants 6 in each. Do I know how many cookies he's going to have?
Yeah.
No. So do I know how many boxes to put out? No. So let's just try. If I make 2 cookies and I put 6 and 6, is that that going to give me 36?
No.
No. Is that too small or too big?
Small.
Too small. Okay. Well, 2's are easy. What else is easy? What else is easy? 2's are easy. What else is easy? Hey, Dawson?
5.
Let's try 5 cookies. 1, 2, 4, 5, 6, 6, 6, 6. How many cookies is that?
24.
No.
Six. 36.
Holy moly. 5 groups of 6. 5, 10, 15, 20, 25, 30.
30.
So is 30 equal to 36?
No. So that means 6.
Oh.
You need one more. It's 6.
So we need just one more group.
6 times 6.
1, 2, 3. Does that equal 36?
Yes.
Yeah. So the equation you were trying to figure out was the whole 36 divided by something give you 6. Could you change that into a multiplication equation?
Yes.
Change it into a multiplication equation.
What?
Kayla?
6 times question mark equals 36.
Beautiful. 6 times question mark equals 36. For a lot of you, multiplication is way easier than division. It might be easier for you to think about it this way. Right? What's that? Uh-huh. Very nice. Hayden? Go for it. Our division symbol looks like this. And our subtraction symbol looks like this. He said those are really similar, except division has those 2 dots. But other than that, they're the same symbol. And then when we look at multiplication and addition, they're almost the same symbol, but multiplication is turned. I wonder why those symbols are so similar. Division and subtraction, and then multiplication and addition. I wonder why those are so similar. Parker, what do you think? Maybe. Do we know multiplication and addition are related?
Yes.
Are division and subtraction related?
Yes, because they're both taking away.
Interesting. All right, go ahead and turn the page. Title it, part, whole. Georgiana, what's up?
On the cookie problem,
Uh-huh.
the one where you guys take one that is just cookie. Why couldn't we have just done a big array and then put 6 and 20 on it?
You can. That's exactly what we did. We just didn't do the same picture. It is the same math, and if that works for you, that's perfect. It's the same math, we just did a different picture. Okay? Somebody remind me, what is my addition equation if I'm using a bar model? Parts and holes and stuff. What does it look like? Parker's the only one that knows. Mason, do you know? What is it? Good. Go ahead next to the word addition. I want you to write part plus part equals whole. We know that. That's second group stuff. What is it for subtraction?
Whole part.
That in your any equals, that in your any operation. You just said 3 words in a row. What is it for subtraction? Damien?
Whole minus part equals part.
Awesome. Think back to when we did multiplication. What are we thinking? Ella, what do you think? Roughly part times part. It's not the same kind of parts as this, though. You see what I'm saying? So it's going to be part, like our groups.
What, you don't recognize me? Same time of day. So took a long break.
Yeah. So remember, it's not the same thing as part whole or just adding. It's not quite the same. Talking about groups, those boxes in our bar. Times how many? Okay, cool. If you're writing this down, gentlemen. Okay, Brian, I'm talking to you. What about division? What do I start with division? Probably going to be something very similar to its like buddy. What do I start with when I'm dividing? A group? Parker? The whole. Divided by part, which is could be a group, equals part, number in a group. Which ones look similar? Which ones look similar? Gorilla? Similar.
My division looks like minus and multiplication and addition look the same.
Isn't that crazy?
Because they both are in the same basket.
Kinda. Very cool. Once you